Hey, so let's solve this old school problem. I think this problem is showing the TED. Yeah, so the brain teaser problem is not related to coding, but Bob switcher. Okay, so there are unbobs, there are initials off, right? You turn on all bobs, and now third round so basically in the first round you touch all bobs, you every second bobs, and in the third round you target every third bobs. Okay, so and you need to return a number of bobs there after they're on after and off. Also, I think you just try an arrow and you will find the hit. Right, so basically in the first round everything is on, and the second you touch the second, right? So this is off, the third you touch this. Okay, so yeah, so let's quickly solve it. So these problems can be solved using your problem, right? So basically, what is the, let's say we have so what is the number of touches on ice bobs? Okay, so initial, okay, so after let's say after m rounds, right? Let's say m rounds. Okay, so if m greater than I, then there's no way that you can touch, right? So and then in the beginning you've touched first, and then touching the multiple of 2, and then touching multiple of 3, and touching multiple of 4. Okay, so you can easily say that the number of the touches on I is the same as the which mathematician called tau of I, which is x. Let's say from 1 to I, such that I x is divides I, or I mod x, which is 0. Okay, so yeah, this is the answer. Okay, so all we need to find is that things. So for example, the number of let's say tau of 3, which is 2, right? Because it's basically 1 and 3. 1 is divisible by 1 and 3 is, so it's a number of factors. Okay, so all we need to know is that which guy is on, right? So on means that what? On means that the tau of I, which is what? Which is odd. Okay, so this is the theorem. Tau of n is odd if and only if n is perfect square. Perfect square. Okay. So what we mean by perfect square means that the tau can be written as alpha square for some alpha belongs to integer. Okay, it's perfect square. Okay, so let's do the proof. Okay, so let me just write down the answer. Okay, so the answer you just ask how many perfect square. Okay, so in this problem you just take the mass dot sqrt. Yeah, you just take your n, right, and you just take how many square, right? So you need to take an integer, otherwise it will be some irrational number. Okay, so you just return. Yeah, this is the answer. Hopefully. Yeah, that's okay. So let's do the proof. Okay, so let's see. So if n is perfect square, let's prove these directions. So if n is perfect square, then what? Then basically you can write n as let's say p1, a1, p2, a2 up to pk, ak. And since it's perfect square, right? So a1 must divisible by 2, a2 must divisible by 2, 2 must divide ak. Oh, sorry, I'm stupid. So this is these directions, but because I assume that n is perfect square. Okay, so the tau of n will be a1 plus 1, a2 plus 2, up to ak plus 1. Okay, so this is odd. This is odd because 2 divides a2, and this is odd, right? So tau of n is odd. Okay, so how about these directions? So let's assume that tau of n is odd. Okay, and then we know that tau of n must be the product of AI. Let's say AI. Somehow you sometimes become some geometrical shape. So once you are not so high from 1, and let's say AI plus 1. Okay, so if tau of n is odd, that means everyone is odd. So every AI plus 1 is odd, which you get each AI is even. So let's say, so now your n is A1 times some even, right? So P1, A1, P2, A2. So all these are even, right? So you can take the 2 factor out. So basically this is the trivial proof, right? So n is perfect square. Oh. Okay, so that's it. So basically this is the way to solve this problem. Okay, that's it. See you guys next week.